Welcome to our senior secondary mathematics. In this video, we're going to continue algebra factorization part 2. In the previous video, we looked at three types of algebraic expressions and how to factorize them. We looked at the ones with common factors. Then we emphasized that if you have been asked to factorize something, you first have to ask yourself, does it have common factors? If it doesn't have, then it might be a type 2. A type 2 is the difference of two squares, where you have two square numbers separated by a minus. Then from there, if it's not different of two squares, then it can be type 4. We show that type 4 is made up of 4 different terms, and 2 of the terms must have a common factor, and the other 2 also must have a common factor. So you group them in such a way that they have common factor, then you factorize each of them. Then in this video, we're going to take a look at the last type, which is quadratic expression. So type 4 quadratic expressions. So quadratic expressions are algebraic expressions that look like this: ax squared plus bx plus c, ax squared plus bx plus c. So there are too many things to notice. The first one is we have one term that has got x to the power 2, another term that has got x, and the third term which doesn't have x. These variables a, b, and c actually represent numbers. So we can have numbers here like 2, 5, and 6. To make my point clear, let's take a look at some examples of quadratic expressions. So all these are quadratic expressions. Let's start with this one: 2x squared plus 3x plus 5. So we can see that the first term has got x squared, the second term has got x, the third term doesn't have x. So this is a quadratic expression. As you can see, the letters a, b, and c represent numbers. They are called constants in mathematics. Then another example is this one: x squared plus x minus 1. Again, the first term has got x squared, the second term has got x to the power 1, or without a power, if you may. Then the last term doesn't have x, so it's a quadratic expression. The third term, the third expression is this: negative 2x squared plus 3x plus 5, and follows the same pattern. The last term, which is quite interesting, is this one: 2 plus x minus x squared, 2 plus x minus x squared. So this one, the terms are jumbled. They are not arranged like these other three. So even if they are jumbled, it's a quadratic expression, so long as you can rearrange the term to have something that appear like this, where the first term is to the power 2, the second term doesn't have power, and the third term doesn't have x. So we can rearrange to have this. So this first term, I've just written it in front. The second term, I've just left it on the middle. And this, which was the first term, I've just put it at the end. So negative x squared plus x, to first term with power 2, second term without power, and third without x. So it's a quadratic expression. So given an expression like this, and if I've been asked to factorize, you can write it in this form, which is called the standard form. Then from the standard form, you can start factorizing. How do you factorize? That's the thing we're going to learn. So we'll learn through an example, or using an example. So this is an example: factorize x squared minus 3x plus 2, x squared minus 3x plus 2. How do you factorize this quadratic expression? So the first thing you do, you identify two numbers which are called product and sum. By the way, for those who don't know, product is the name given to what you get when you multiply two numbers. For example, 2 times 1, you get 2. 2 is the product of 2 and 1. 3 times 4, you get 12. 12 is the product of 3 and 4. Then sum is what you get when you add two numbers. For example, 2 plus 3 is 5. So 5 is a sum of 2 and 3. What you get when you subtract two numbers is called difference. And what you get when you divide two numbers is called quotient. But in here, we're only interested in product and sum. So you come up with two numbers which are called product and sum. How you come up with this you can use a rough paper. You can do it somewhere, not on where you are working, not on the sheet or the paper you're working on. So you can just use a rough paper. So somewhere you can come up with a table like this. So uh, you write product sum. So down here is where you're going to put your product, and down here is where you're going to put your sum. So how do you get the product? The product, you get it from, you multiply the coefficient of the first term and the last term. The coefficient of the first term and the last term. The coefficient of the first term is 1 or positive 1. So you multiply positive 1 and positive 2. So here I just wanted to show that the first term coefficient is positive 1 and last term is positive 2. So positive 1 times positive 2, you get positive 2. This positive 2 is your product. The sum is just the middle number. So the middle number is negative 3. It's not 3, it's negative 3. Always be mindful of signs. So the middle number is negative 3, and that is the sum. So you write the sum here, negative 3. That's the first part of the job. The second part of this job is you come up with two numbers, or you think of any two numbers which, if multiplied, gives you positive 2, and if added, gives you negative 3. So come up with two numbers whose product is positive 2 and whose sum is negative 3. So how to do this? I'll give you two hints that help me when coming up with a product and sum. So you do trial and error, where you test different numbers till you get the actual numbers that are going to give you the product and the sum. So the numbers that you test should always be less or equal to the product. So for this, our product is positive 2. So we're going to test numbers less or equal to positive 2, which are 1 and 2 itself. These are the only numbers which are less than 2 or equal to 2. Then the second is you test both positives and negatives. So you test both positive 1, negative 1, and positive 2, negative 2. So these are the two hints that are helpful. So let's try to get the two numbers which, if multiplied, will give us positive 2, and if added, will give us negative 3. So I'll show you what's going on in my head as I'm trying to come up with the two numbers. So I'll start with 1 and 1. So 1 and 1. So 1 times 1, it's 1. I want positive 2. So these ones are failed. I'll try maybe the negative forms of these numbers. So I'll try negative 1 and 1. I've just changed the sign of one of the numbers. So negative 1 and 1. So let me try. Negative 1 times 1, it's negative 1. I want positive 2. So no. I'll try another one. I've added negative here so that I test also the negative of this one. Negative 1 times negative 1 is positive 1. So, nope. I try another one. Of course, I said numbers that are less or equal to the product. So, 2 qualifies. It's equal to the product. So, 2 times 1, it gives us 2. So, 2 times 1 has given us positive 2. So, it has qualified. But for it to qualify completely, it has to satisfy the sum, which means when we add the numbers, we have to get negative 3. So 2 plus 1, we're getting 3 or positive 3. We're looking for negative 3. So these two have failed us. So keep on trying. What if we change the sign of one of the numbers? Let's say we change 2, it becomes negative 2. So 1 times negative 2, it gives us negative 2, but we want positive 2, so it has failed. We try to make this also negative. So negative 1 times negative 2, it's 2 or positive 2. It has succeeded. Let's go to the sum. Negative 1 plus negative 2. That's negative 1 plus negative 2. The signs are the same, negative and negative, so we are going to add them. So negative 1 plus negative 2 is negative 3. So this one, negative 1 and negative 2 are the two numbers we are looking for. Once you have these numbers, you do this second step. So you replace your sum with your two numbers. So negative 3x should be replaced by negative 1 and negative 2. So how you do this is, where there's negative 3x, you just put negative 1 with x and negative 2 with x. So don't forget the variable that is attached to this middle number here. So negative 3x, you remove 3, you put these. So you have negative 1x and the negative 2x here, like so. So x squared, negative 1x, negative 2x plus 2. When you reach here, all the new things that were, there's nothing new that you are supposed to learn on how to do this. When you reach here, you have turned this quadratic into the type 3 expression. Remember, type 3 expressions have 4 terms and 2 of the terms have got common factors. If you see here, x squared and negative 1x, they have got a common factor. Negative 2x and positive 2 have got a common factor. So you have changed quadratic expression to type 3. Now you can factorize it the way we were factorizing type 3s. So I will start with these two and we'll go to these two. So we'll look for the common factor, x squared and negative 1x. The common factor is x. So we can factorize x. X into x squared is going to be x. X into negative 1x is going to be negative 1. We go here again, common factor, negative 2. So we can say 2, but it's even negative 2, it's okay. But you have to be careful because what's here, what is going to be in the brackets here should be the same here. So that's what is going to guide you whether to choose negative 2 or positive 2. Let me just write what we get on the next stage for you to understand. So here, x. So x squared divided by x, we got x. Negative 1x divided by x is negative 1. Cool. We go to the second one. So let's say we're chosen 2 here as the common factor. So if we're chosen positive 2 here, positive 2, negative 2x divided by positive 2 is negative x. This is not the same as this. I explained this when we're doing type 3, that be careful here. So it won't, the terms in the brackets won't be the same because this is going to be negative x and this one is going to be x. We want here to have x. So the best choice is to choose the negative 2, not positive 2. So negative 2. Negative 2x divided by negative 2, it's x. Positive 2 divided by negative 2 is negative 1. Once you have the same things here and here, then you can be assured that whatever we're doing is correct. So from here now, you can factor out x minus 1, which is common to both. And you have this x minus 1 and this thing which were outside the brackets, you group them, x minus 2. You have factorized a quadratic expression. So this part here, this thinking here, the marker doesn't care. Then what they want is just to see this happening, not this. So this you have to do it somewhere, and you can learn how to be fast. You're not supposed to be writing this. If you, or maybe when you're starting, you can be doing this where you try numbers, but when you become an expert, just think in your head, okay, I'll start with 1 1. 1 times 1, it's positive 1, so it has failed. You go to negative 1 and 1. Negative 1 times 1, it has failed. You keep on doing that till you find the two numbers that are going to satisfy these two conditions, the ones that are going to give you the product and the sum. Let's try another example. So we have x squared plus 3x plus 2. So again, I'll do, sorry, yeah, so I was supposed to do some some rough work, but anyway, let's do this. So this is how it should be solved. So let us just go through it. X squared plus 3x plus 2. So you go and do your rough work here. So you ask yourself, first term it's 1 and last term is positive 2. So you multiply these numbers, positive 1 times positive 2. They have given you the product, positive 2. What is the sum? The sum is the middle number, positive 3. So this is positive 3. So what are the two numbers? So start thinking, what two numbers are going to give me positive 2 and they're going to give me the sum, positive 3. So you start with 1 and 1. So 1 times 1, it's 1. So anything that has to do with 1, when you multiply it, whether it's negative or positive, it always be 1. So, or negative 1, 1, it cannot give you 2. So we can skip trying ones. Let's go to maybe 2 and 1. So 2 times 1 is 2. Okay. What about if we add 2 and 1? 2 and 1, that is 2 plus 1. It's going to give us positive 3. So this has succeeded, which means our numbers are 1 and 2, or positive 1 and positive 2, which we can replace this middle part here. So x squared plus the first number 1x plus the second number 2x. If this number was negative, well, it could have been negative 2x here. So we just get with the signs. That's why I like putting the signs here so that when you're transferring these numbers here, you know that they are going with the signs. So x squared plus 1x plus 2x plus 2. When you do this, now it's type 3, we can start factorizing. So common factor between these two, it's x. X squared divided by x is x. 1x divided by x is positive 1. This time, it's okay. We can try positive 2. Positive 2x divided by positive 2, it's x. Positive 2 divided by positive 2, it's positive 1. Then we can factor out x plus 1, which is common in both. So x plus 1, then we remain with x plus 2 outside, which we put in brackets. So this is how to tackle this. So the only time consuming part is here where you figure out the numbers. You have to do at least 6, 7, 8 questions for you to become good. But others, of course, are already good, I know. Another example, 4x squared plus 8x plus 3. So product first. What's the product? Product first term coefficient multiplied by last term. So 4 times 3, 12. So these are how I was identifying the first term and the last term, positive 4 and positive 3. Positive 4 and positive 3, you multiply them, you get positive 12. This is your product. Sum the middle number, positive 8, positive 8. So what are the two numbers? If multiplied, will give you positive 12. If added, will give you positive 8. So we think using the product. So we're looking for numbers which are less than 12 or equal to 12, which if multiplied will give you 12, and if added will give you positive 8. So let's try to think. Let's look for any numbers which if multiplied will give you 12. We can even start with 4 and 3. So positive 4 times positive 3 is 12, but is it going to give us 8? Positive 4 plus positive 3, it's positive 7. So no. Let's try out something else. What about 12 and 1? 12 and 1 gives us 12 when you multiply them. 12 times 1 is 12. But what if we add them? 12 plus 1, it's going to be 13. Even if we try the negatives, negative 12 and 1 are not going to give us 8. What about 6 and 2? So positive 6 times positive 2 is positive 12. What about positive 6 plus positive 2? It's positive 8. So positive 6 and positive 2 are the ones we're looking for. So when you reach this stage, we go to replacing. This should be replaced with positive 6x and positive 2x. So we do that. 4x squared, positive 6x, positive 2x, positive 3. Then we deal with now it's type 3, so we can factorize these two and these two. So here, what's the common factor here? For the numbers, it's 2. 2 is the common factor of 4 and 6, and for the letters, it's x. So we have 2x. 4x squared divided by 2x is 2x. 6x divided by 2x is 3. Then we'll go this side. What's the common factor between 2x and 3? There's no common factor because we don't have a common variable. And the two numbers 2 and 3, the only common factor they have is 1. So we use the same one. So 1 here. So 2x divided by 1 is 2x, and 3 divided by 1 is 3. So these are common, as you can see. So we can factor out 2x plus 3. And when we do that, we're going to have 2x plus 3, open bracket. The things outside the bracket, we group them 2x plus 1. Let's take a look at the last example. Negative 3x squared minus 19x minus 20 minus 3x squared minus 19x minus 20. By the way, I'll emphasize again, minus and negative are one and the same thing. So this is minus 3x squared minus 19x minus 20, and it can also be read as negative 3x squared negative 19x negative 20. So again, we have to look for the product and sum. What's the product? First coefficient, or the coefficient of the first term multiplied by the last term. So negative 3 times negative 20. So negative 3 times negative 20, which gives us positive 60. Then the sum is the middle number, negative 19. Ooh, ha. So we have to look for those two numbers. If multiplied, it gives us positive 60. And if added, it's going to give us negative 19. What are the two numbers? So let's try any two numbers that instinctively or intuitively you feel like when you multiply them, they are going to give you positive 60. For example, 30 and 2. I know 30 times 2 is 60. But is it going to give us negative 19, 30 and 2? So 30 times 2 is positive 60, but 30 plus 2 it's 32. What if we make one negative? Maybe let's say 2 is negative, so that it becomes 30 plus minus 2, which is just 30 minus 2. It's going to be 28. So they are not anywhere close to negative 19. Let's try something else. 10 and 6. Yes, 10 and 6. 10 and 6 are going to give us 60. So 10 times 6 is going to be positive 60. 10 plus 6 is 16, not 19. And if we make either of them negative, still we cannot get negative 19. For example, if we make 6 negative, 10 plus minus 6 is 10 minus 6, which is equal to 4. If we make both of them negatives, negative 10 plus negative 6, just the same as negative 10, negative 6, which is negative 16. So it's not going to give us negative 19. So let's try something else. What about 15 and 4? 15 times 4, it's 60. So what about when we add 15 and 4? 15 plus 4 is 19, not negative 19. We're looking for negative 19. So let's try out the negatives, the negative form of 15 and 4. What if we make 4 negative? So it becomes 15 plus negative 4. First, let's try to multiply. 15 times negative 4 is going to be negative 60. We're looking for positive 60. So the base is to make both of them negative so that when we multiply them, we get positive 60. So negative 15 times negative 4 is going to be positive 60. What if we add them? Negative 15 plus negative 4, negative 19. That's the magic right there. Negative 15 plus negative 4 is negative 19. So these are the two numbers. So we replace here. So all these negative 19x will go and it will be replaced by negative 15x and negative 4x, like so. So negative 3x squared minus 15x minus 4x minus 20. From here, we'll deal with these two and we'll deal with these two. So we factor out, we start with the numbers. What's common here? 3 and 15, they have got a common factor, which is 3 itself. And what about the x? Yes, the variables also, the common factor here is x. So we will have negative 3x. If you want, you can go with 3. It's going to give you the same thing. But me, I chose negative 3. So negative 3x. So negative 3x squared divided by negative 3x. We're going to, the 3 is here. We're going to cancel. And x power 2 divided by x is going to be x, or x power 1, which is just x. And negative 15x divided by negative 3x. So negative 15 divided by negative 3 is positive 5. X divided by x is 1. So 1, which means they have cancelled. We go here. We can choose between when it comes to common factors, we don't have common variables because we have x here, we have nothing. So we'll do with numbers. So we'll start with, we can tell that the highest common factor of 4 and 20, it's 4. So we can use positive 4 or negative 4, but you have to make sure that what you're going to get here should appear the same as here. So me, I tried negative 4. So negative 4x divided by negative 4, you get x, and negative 20 divided by negative 4, you get positive 5. So they are the same, which means I'm okay. If I'd gotten something here, I could have changed this to positive to try and see if I'm going to get the same. So with this, we can factor out x plus 5, which is common, and the terms after the brackets, which are negative 3x and negative 4, we group them, negative 3x, negative 4. So this is how to deal with quadratic expressions. So all these that we have learned here, they don't end here. Mathematics is designed on a build-up principle, like the way you build the house. You start with the foundation, you add the block. On top of that block, you're going to add another block just like that. If the lower block is weak, it means the whole building is going to be weak. We started with number systems, where we learned fundamental concepts of mathematics, which we are using here. The integers, the indices, they are the same concepts we're using here. So these, the factorizations, are going to be used in another topic, equations. So whatever you're learning, it's not just something that you'll be applying in this topic. You'll be applying it in different topics. There are some topics which are unique, like sets. Most of the concepts that you learn in sets cannot be applied in other topics. But there is another topic which might need that information from sets. But algebra and number systems, like I emphasized at first, are the most important topics in mathematics. If you are good at this, mathematics will be easy. So this marks the end of factorization. The next and last part of basic processes of algebra is algebraic fractions. Once we're done with algebraic fractions, then we can say goodbye to algebra. Hope you like this video. Make sure you like, subscribe, and share. Otherwise, happy solving.